Hello student, welcome to another tutorial video from Agri Education, and today's lecture is particularly combined to a number of topics. So you can see the subject of this today's module: the structure and function of carbohydrate, proteins, nucleic acid, enzymes and vitamins. These are the 5 different topics has been combined in this particular chapters and make it summarize and brief and to the points, as well as so many questions can come into your final exams as well as MSc entrance examinations, as well as different competitive exams that are based on plant science after immediate completion of your graduation and masters. So there are some tricks I have used, formulas I have used to complete these whole sessions under this category. So you can see here, first one, carbohydrate we can see. So carbohydrates, what is the formula of carbohydrates? That is very important. We can see carbohydrate is the organic compounds with an empirical formula is CH2 or whole n. That means CH2 or whole n. That means, so we can write down this thing in such a way. Just see here, I just can write down the empirical formula CN. If I classify this thing in broadly, CnH2n ON. These are the empirical formula. So you have to remember this thing. If you have been asked for the number of carbons, if in some questions number of carbons are mentioned here, you can easily go for guess share for this hydrogen number and oxygen number. So total formula you can easily calculate from this single carbon atom, dual carbon atom, 2 carbons atom, 3 carbons atoms, 3 carbons glucose, 4 carbon glucose or hexose sugars, whatever it has, you can easily understand. So the next is, it is classified into, another thing is, this is called monosaccharides. So carbohydrates has a first criteria. It is classified into 3 main groups, that are monosaccharides, oligosaccharides and polysaccharides. So first of all, we'll discuss about saccharides. Saccharides means sweet taste. Saccharide means sweet taste. This is the particular term come from. That's why if mono means this is a single monomeric unit of carbohydrates presents into the system, monosaccharides. So simple sugars that can hydrolyze into smaller units under reasonably mild conditions. So very simple sugars, under the attachment with the waters, it can easily hydrolyzed and get its soluble. So you can say that monosaccharide is highly soluble into the systems. It contains a single carbon chain. So first criteria is single carbon chain. CnH2n should be single carbon chain. One single carbon chain consists of a number of atoms. It may be pentose, it may be hexose, but it should be single carbon chain, one by one. It is classified into 2 categories, aldose and ketose. So aldose means it should have aldehyde group in one end, one functional end. It should have aldehyde group. Aldehyde means CHO. We know the formula. Aldehyde means CHO. Whereas if it has one functional unit at the terminal ends with ketone group, that means CO, then it will call ketose sugar. So aldose sugar, the examples of aldose sugars, suppose these are the sugars with the terminal CHOL, what I told earlier, aldehyde groups. Examples: arabinose, ribose, deoxyribose, glucose, galactose and mannose. So these are the simple sugars. So at first I can easily remember, I can recapitalize your from your text. One thing's glucose. Glucose is a pentose carbon sugar. We can easily write down the figures. If we Glucose has a 2 different structural form. One is open form, another is closed form. How we can write down the open form? Suppose C1 C2, C3. Suppose this is hexose sugar, C4, C5 and C6. 6 carbon atom. The terminal carbon, there should be, if it is aldose, then it should be, suppose this is glucose, aldehyde. So it should have CH, CH, CO and CH here, and we can see here CHO, that means aldehyde groups. These are connected, interconnected to each other. So this is the like things. So how we can remember this thing? This is the number 1 carbon atom, number 2, number 3, number 4, number 5, number 4, number 5 and number 6. Okay, so the drawing is very difficult here, but still you have to remember in this way. There is no such other ways, so you can easily remember if after seeing my drawing. So CHO, aldehyde groups, first one carbon atom is this, second one, the HOH orientation is like this, second one, the third one in the third carbons, the OH is the left side. You can easily remember, the OH is the left side, H is the right sides, and remaining are the as it is same. You can see, just see here, HOH and HOH. This is H actually, this is OH, and finally HOH, and another group should be present at the terminal, that is H, hydrogen group is there. So how many hydrogens, you can see how many hydrogens are there, 1, 2. So at first CN, H2N, ON, how many numbers of carbon? 6 carbons, C6. How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C6, H12, and finally O6. O6 how? 1, 2, 3, 4, 5, 6. C6, H12, O6. So the empirical formula of glucose or hexose sugar is hexose, because it is hexose carbons are there, number of hexagonal. If it is 3 carbon, that means triose. 4 carbon, tetrose. Triose, tetrose, pentose, hexose and heptose. These are the different things I can talk you in oligosaccharides part. So the next one, it contains a single carbon chain. It is compounded. If it is replaced by keto group, CO group, then it is called keto sugars. Keto sugar is also another type of hexose sugar. Example is dihydroxyacetone. It is very, very important formula, important name. And fructose sugar. Fructose sugar is also again the formula is changed, whether only this group is like this. Keto sugars means that this is not present. This is not present. So how it will maintain that total strength or bonding efficiency? You can see here COO group. Now it will be remarked as one van der Waals bonding is there. So next one is oligosaccharides. Oligosaccharides means more than one units of monosaccharides are present. When two or more monosaccharide units of different or identical types join together end to end to form oligosaccharides. This is the first conditions. So students, you have to remember, for oligosaccharides the number of units, monosaccharide units, from 2 to 7. Monosaccharide, the minimum number is 2, maximum number will be 7. If it is more than 7, then we can say this is polysaccharides. This is the common number. Oligosaccharides contain 2 to 7 number of oligosaccharides, monosaccharide units. So how we can represent this? If 2 number of monosaccharide units are attached together, so it will make disaccharides. We can say also disaccharides, but it is appropriate to say oligosaccharides. So one type of disaccharides examples are sucrose, maltose, lactose and cellobiose. Students, so many questions are coming. What are the monosaccharide units attached to each other to form sucrose, for maltose, how lactose are formed, and silobiose are formed? All the things are given in the examples. Trisaccharides, this is disaccharides, all are under trisaccharides are gentianose and raffinose. Where raffinose is found in under rhizomes content crops. Tetrasaccharides, example is stachyose. Pentasaccharides, pentose. Pentasaccharides, example is pentose sugar. Pentose sugar's example is ribose and arabinose. Ribose, you have to know this thing. It is not written here. Tetrasaccharide, after that tetra means 4. 4 monomeric unit, monosaccharides units. Now about the sucrose. Sucrose is a combination of two sugar, glucose plus fructose. You can see here the glucose unit I have shown you. This is the closed chain I can show here now. That was the open chain structure of glucose. This is the closed chain structure of glucose. So this is the oxygen molecules. It is attached to this carbon here, carbon 1, 2, 3, 4, 5 and 6. Okay, so you can easily remember. Now the valency for this would be, for glucose will be like this: oxygen and this is hydrogen. So this is the 6th carbon atom and this is the 1st carbon atom. So when two glucose plus glucose, galactose, glucose plus fructose is called sucrose. So in case of sucrose, what will be the changes? I can see this is one type of non-reducing sugar. Non-reducing sugars means the another structure. If the another structure of fructose, I can draw the attention here for you. You can see here all the things are same. Now the hydrogen oxygen. Now all the things have this bonding, hydrogen and oxygen. So in case of glucose, the hydrogen bonding between first glucose unit and second fructose units, where it will be bonds together. You can see here 1, 2, 3, 4. 1/4 unit. That means 1/4 number of carbon atoms will be involved. This is the number 1. Here the hydrogen, and this is fourth number, 1, 2, 3, 4. So whatever the carbon is here hydroxyl group in the up sides and oxygen group will be the lower sides. In such way, here the oxygen group is with upper sides for glucose, upper sides, and hydrogen OH group is with the lower sides. So this is the basic difference between glucose and fructose. Now how it will attach? Number 1 carbon. So we know that the linkage should be 1/4 linkage. 1/4 linkage, 1/4 linkage means inverted. This is the say OH 1/4. How it is possible? This is number 1. This is number 4. So this particular ring will be removed. One water molecule will be released from here, and this particular bonding will be situated to make disaccharide units. So it is commonly called as a cane sugar because very, very sweet. Beet sugar or saccharose also. Maltose and cellobiose. Cellobiose is these types of sugars are the products of partial degradation of polysaccharides such as starch and cellulose. So when starch and cellulose are degraded by adding of waters, so initial products will be maltose or cellobiose. Okay, so both are the reducing sugar. Reducing means when they are making the point Maltose consists of 2 units of D-glucose. Glucose plus glucose will be maltose. Students, it is very remembering things, remembering points. Joined together by alpha 1,4 linkage. Alpha 1,4 linkage means straightforward. HOH is here, and in another glucose molecule or monosaccharide molecule, it should be like this HH. Okay, I should keep it here, H and OH. Straightforward linkage. Orientation will be the same way. If the beta 1,4 linkage, 1 and 4 linkage will be opposite. OH in the upsides and H is the lower side, reverse. So in this way, alpha 1,4 or beta 1,4 linkage will be defined. Cellobiose consists of 2 D-glucose units joined together by beta 1,4 linkage. Okay, you have to be remember. Lactose. Lactose is the known as the milk sugar. In the milk, this particular sugar is basically present. It made up of 2 smaller sugar molecules. Basically, this type of questions are coming. Lactose is the combination of 2 monosaccharide units, glucose plus galactose, glucose plus fructose, glucose plus sucrose, whatever. You have to be remembered, this glucose plus galactose will be lactose. Stachyose, it is one type of tetrasaccharides. This is a very critical typical examples of tetrasaccharide, that is stachyose. It consists of only 1 unit each of glucose and fructose and 2 units of galactose. That means total 3 different bondings are there and 4 different units are attached to each other. Reducing sugars, what is the definition? Reducing sugars are the any sugars that capable of acting as a reducing agent during their free aldehyde or keto group, where non-reducing sugars carbon elements of aldehyde groups are bonded by a aglycosidic bond, unable to make an open chain structure. So I have shown you glucose. Glucose has an open chain structure. It has also closed chain structure. So it is considered as, so you just have to remember those particular saccharides have that capacity to make open chain structure, that is reducing sugars. Okay, yes, reducing sugars, and those are not capable of open chain structure, then it will call as a non-chain, non-reducing sugars. D-glucose, what do you mean by D-glucose? I have asterisk that point. D-glucose is a short form of dextrorotatory glucose, means under isomeric conditions the rotation will be like this. Dextro means clockwise and levo means L-glucose is also there, but in nature L-glucose, the number of the types of L-glucose is very less. D-glucose is highest number of proportion of D-glucose that presents. One of the 2 stereoisomers, this is the isomeric. L-glucose and D-glucose is nothing, they are the typically isomers to each other. You have to know this thing. And under isomeric conditions, the rotations will be dextrorotatory or levorotatory. That's why their name suggested. So of glucose, where the hydroxyl group of 5 carbon is on right side, but it is on left side in case of L-glucose. The 5th carbon I have shown you in the earlier picture. You can see here. I have drawn one picture here. Hydroxyl group of the 5 units in the left sides for dextrose. This is the 5th group. Hydroxyl with the left sides. That's why this is D-glucose. If hydroxyl group in the opposite sides, if it is here and OH group is here, then L-glucose. In this way it has been classified. After that, polysaccharides. Polysaccharides, the number of one examples, a number of monosaccharides are attached to each other by glycosidic linkage to make polysaccharide. It is polymerized form of simple sugars and consists of a large number of carbon atoms. It is of different types. First one type is starch. Starch is a very good storage polysaccharide examples in nature, and it has the only one conditions. It is usually present in plant kingdom. A number of storage areas are there in the plant's tissues where it has been stored as a starch. Number of grain crops we have seen that are basically the starch carbohydrate products. It is one type of storage polysaccharides. It has a hexosan polysaccharide made up of large number of glucose unit. So that means a number of glucose are attached to each other by glycosidic linkage. So make a single polypeptide ring chain-like structure to make starch. So starch and glycogen. No, starch and cellulose. What is the difference between starch and cellulose? We have to know that thing. It is mostly found in rice, wheat, grains, other cereals, legumes, potatoes, tapioca, and banana. Cellulose. What is the difference? It is type of structural polysaccharide. This is the storage polysaccharides. This is the difference. So basically, polysaccharides basically present in plant system as a starch, stored as a starch, stored as a starch. SS you can write down here. Then um, it will make structure by cellulose enzyme, cellulose structure, cellulose form. It can distribute it or transmit it from one location to another location through fructose. You have to be remember all the things, and it is present in the systems in the form of simple sugar, that is called glucose. So these are the four different forms that are typically present in a plant systems. So it is the most abundant organic compounds found in the biospheres. In the earth is the highest content of polysaccharides, organic compounds present in the earth. So it is also chief constituents of cell wall. Cell wall, it is the main component, and alpha form is the most common forms of cellulose, alpha form, and cotton fibers. These are the examples. Cotton fibers have 90% cellulose content. So glycogen, what is the typical type of polysaccharides? It is one type of storage polysaccharides. In the animal cells, in the plant cells, it is starch. In the animal cells, the form is different, but the structural units are similar. The main part is storage polysaccharides. It is present in only animal cells. Pectin, another type of polysaccharides. It is a polymer of galacturonic acid. This is called, also questions come into the exams. It is normally present in cell walls as a calcium peptides. In cell wall, it is also present